Our second topic for the day is to learn and apply the properties of definite integrals. First, it's important to note that all continuous functions are integrable on a closed interval. That means we are able to evaluate an integral or find the exact area on a closed interval. So integrals have several properties that, if you apply them, can actually make an integral easier to evaluate. Let's look at the different types and see if we can apply it to examples. The first property is called the zero property, and the first thing you should notice about that integral in the example is that the lower and the upper limit are exactly the same, and that produces an area of 0. So let's think about why that would be. If I were to look at the example of a linear function, 2x, and I tried to find the area from 1 to 1, that does not produce a two-dimensional shape. So there's no way to find the area on a interval that has no second dimension. So that's why we get an area of 0. The second property is called a constant multiple property, and that's when you have a function in your integral that's being multiplied by a constant. And if it simplifies the integral for you, you can actually take that constant and pull it out in front of the integral and then just evaluate the integral of the function itself. So in this example, we see that we have a 2x in our integral, but the 2 is a coefficient or a constant that we can pull out in front of it. So that would be equivalent to 2 times the integral of 0 to 1 x dx. And so we could leave that 2 out front and then just evaluate or find the area between the function x and the x-axis from 0 to 1, which I went ahead and graphed here. It is a triangle with dimensions of 1 and 1. And that gives us a final answer of 2 times a half, which is 1. The next property is called order of integration, and you might notice that the limits are supposed to go from a to b, and in this example, they're backwards. So if you ever need to change the limits because the lower limit is actually a greater number than the upper, you can do so by actually inserting or putting a negative out in front of your integral, and that corrects the order of integration. So in the example for this property, we see that the 0 and the 1 need to be switched because your lower limit should always be the lesser value. And to make that switch, I need to go ahead and put my negative in front of the integral. And it's still of 2x dx. And so that negative stays as a coefficient. And we found out in the last example that the value of the integral from 0 to 1 of 2x dx is 1, so that gives us a final answer of -1. Next are the sum and difference properties, and they work very similarly. It's if you have two functions in the integral that are being added or subtracted. If it simplifies things for you, you can actually separate the sum into two integrals, so the sum of the integral of each function separately. So for the example, we have from 0 to 1 of 2x plus 3. So we can separate it right where the plus is, meaning that each of the functions is now in its own integral from 0 to 1. So it becomes the integral of 0 to 1 of 2x dx. Then you keep the sum, and we still have the same limits, and now this one is just the integral of the 3 dx. So the difference example would be set up very similarly, just with the minus instead of the plus. And to evaluate those two, we know from our example of the constant multiple property, the value of that first integral is 1. So I'll put that in, and then plus, minus. And on the front of our notes, we learned how to do the integral of a constant function, because 3 is a constant, it doesn't have a variable, by using that c, which is our constant, times the b minus a formula. So 3 times 1 minus 0. So calculating that would give us 4 for that sum, and then -2 for the difference. The last property that we can use is called the additive property, and it's when you have two integrals of the same function with different limits, But you might notice that the upper limit of the first integral is the same as the lower limit of the second. And so the two integrals can be connected in this way because they match up at that same x value. So if you want the area from A to B added to the area from B to C, what you can do is just find the total area from A to C. So you're basically cutting out that limit of B, and this should feel familiar to you maybe as part of like a transitive property that you learned back in geometry. In our example for additive property, we see that we're looking at that function 2x again. We are looking from the area from 0 to 1, and we're going to add it to the area from 1 to 3. So it might help you to visualize it by looking at the graph. So we've learned a couple times today that the area from 0 to 1 of 2x is 1. And then if we add it to the area of 1 to 3, it happens to be a triangle of 4 and 4. So putting that together, I can eliminate that limit of 1 and just go from 0 to 3 of 2x dx. And that gives me the total area added together, which would be 9. When we get together as a class, we'll be looking at these examples together and trying to apply the properties. And these are given pieces of information that we'll use to substitute in. So if you have a chance and you feel comfortable, see if you can go through each example and just try to recognize what property from the table above you might see in each one. Some of the examples have just one property to apply, and some of them, as you get down the list, have more than one properties involved. So see if you can at least try to recognize one, and if you feel comfortable, try applying it and plugging those in. Otherwise, I'll help you when we get to class.